All right.
Never heard of this before.
So the definition that we used last time was numbers describing characteristics of a sample. And so, and then those numbers have been consolidated or summarized from the raw data. But what you really want to take out of that when we talk about sample statistics, those numbers are completely drawn from only the sample, not the population. Is that
Okay.
all right? And then when we talk about population parameters, those are things of interest, and we end up using the sample statistics in order to infer what the population parameters will be. Right, but all the numbers. So when we go more in depth and we're talking about what maybe the mean or median of a particular sample, there's going to be sample statistics that we drew and we got from only the sample.
Mhm.
Okay.
Okay.
All right. Anything else?
I think that's it with me.
Okay. Any other questions from anyone, Casey or Aiden?
No, I'm good.
Okay,
No, I'm good.
so next section. It takes too long to go through it. And it's what we're going to do tonight. So 5B. Basically, it's entitled, should you believe a statistical study? And so, if anything, this is probably the most important thing for us, because we're just bombarded with information daily. And so when we see studies and evaluating, should this be something that we take seriously, or should we have reservations and doubts? So, but it's not just enough to have reservation and doubts. Why do we have reservation and doubts? And so that's what we want to look at. What are the things we're going to use to evaluate any particular statistical study? All right, so let's look at some guidelines for evaluating a statistical study. All right, I don't know if I can get them all on this page or not. All right, so number one, we want to get I'm going to put this in quotations, big picture of the study. So we want to, what is the goal? So those things we had lined out last Thursday in terms of what is in a statistical study. So what is the goal of the study? What is the population that we are studying? And is the study observational or experimental? There's two types of study that we looked at last time. So big picture view. What is the goal? What is the population? And what kind of study is it? Is it observational or is it experimental? So that's our jumping point in terms of evaluating. So the next thing, let's look for bias in the sample. So
What's the sort you see
decide whether the sampling method was likely,
there?
so we looked at different types of sampling methods, simple random sampling, stratified, um, convenience, systematic. Those were the 4 types that we considered. But at the end of the day, what do we want the sample to do? Is it representative of the population? So we want to know what was the sampling method, and would that lead likely to produce a representative sample? Right. So that's the next thing we want to analyze. So consider the source. All right. So that is, who's the researchers? So a classic example, and I brought it up last time, the tobacco companies were famous from the 70s and the 80s, before they got really, really hammered in the courts for conducting statistical studies saying that smoking, had no ill effects. So, what got them blasted in the courts was they actually had done studies and they knew back in the 40s that it had definitely, there was a very high correlation to health effects, and they hid that. So, but they had a certainly a motive for coming out with a data that's saying that smoking was okay because they had a vested financial interest in it. So, but always consider who was doing the research, or if and I'm not, I like to get into politics, and this could fly either way. If the Democrats finance a study on a Republican spending bill, well, there's a good chance they're going to say, oh, it's bad news and that sort of thing. Again, they have a vested interest in coming up with those conclusions. So you have to be dubious. That there's going to be inherent bias in that kind of study. All right, so consider the source. Basically, who's the researchers, and could that introduce bias? Okay.
And then with that tobacco company, what kind of study would that be?
Well, they did both observational and experimental,
Okay,
or so they claimed. So,
okay.
all right, in terms of that. All right, now, this one we got to have some more discussion after I get through this list of guidelines, because this is now I want to talk about something we really hadn't talked about up to this point, but we're going to look for problems in defining
That's okay with that. Make so much money.
or measuring what we're going to call the variables of interest. And that's what we're going to have more discussion on. So, but these would be the things we're interested in studying. Okay. So basically we have to, define very clearly what it is that we are interested in studying. So if there's ambiguity in that,
What's my version?
that's, I can't really draw, it's hard to draw any kind of firm conclusions if I haven't really defined very well what it is that I'm wanting to actually pinpoint and study. So,
That has to be flat.
now, so, very quickly, just in terms of defining variables of interest, a variable in itself, just math, if you take an algebra course and we start solving linear equations of one variable, we use a letter. It is a number. It's a what? Unknown number. So the way we define variable is simply a quantity or an item that can take or vary or take up on what different values. So now variables of interest in a statistical study are the items or quantities that the study seeks to measure, which we already said. So those have to be very well defined, what it is, that I'm looking for. And that goes right into when you first put your study together and your goals. So you want to be very clear about what it is that you are studying. So now, going along with this variable of interest, number 5, beware. You're on the lookout for
Gotta make money.
what we're going to call confounding variables. Okay. Now, the word confounding in and of itself definitely does not have a positive connotation. But they are items or quantities that are not intended to be part of the study itself. And what, the issues that confounding variables can raise, it can cause the study to favor a certain set of results unexpectedly. It can cause incorrect conclusions to be drawn from the study. But generally speaking, what you come up with an idea. I want to do this study. I clearly state my goals, and I know exactly what my variables of interest are. And these are just simply things that are there that you really hadn't thought about. So you got to really think it through. Is there anything else that could be there that you're just not thinking about? So, but we'll look at some examples of that here in a minute. But so these are not variables of interest. These are items or quantities that could be there, and you just have to not neglect them. That you have to kind of think them through and take them into account. Okay. Number 6. Consider the setting and wording in surveys. Okay, so there's two different things there. If a survey is done via Fox News, well, there's, or a setting is done by MSNBC. Those are two different audiences, is my point. And so right there, you have a sampling problem. Right off the bat, there's no way to know if it's any way randomly done. You don't know who the TV viewers are, but we do have an inclination that, the folks that watch Fox News are not the same folks, completely different audience that watches MSNBC. So in either case,
True, 'cause that would destroy the law.
the setting in both those cases definitely is going to have a dramatic impact upon any kinds of questions and the results you're going to get from those. And then in and of themselves, the questions and how they're asked is a whole other thing. So what you don't want to do is have types of questions that inherently can produce inaccurate or even dishonest results. So all that has to be taken into consideration. All right, number 7. We want to check the results are presented fairly. Does the study support the conclusions that are presented in the media? And then even how they're presented. And later on, we're going to look at different kinds of ways to show data and how those can be skewed and so on and so forth. And you always have to be out on the lookout for that. But does the data presented does it support the actual conclusions that are being reported? Okay. And then number 8, right here. Stand back and consider the conclusions themselves. All right. That is, do the conclusions make sense? And do they have some practical significance? Okay. So, now, let's talk a little bit about, gotta make sure you guys have all this written down. So I get to turn the page. Okay.
Star food.
Back to bias. So 2 different types of bias you got to think about. First is selection bias. All right. And so this is where we are putting our sample together. And so if we go out and get a sample and the way we conduct it such that it is not representative of the population that we are trying to study, that is going to have a dramatic effect on the outcome and on our conclusions. So if and this has definitely happened in the past. So when you politics seasons, and if you conduct or you go out and get your sample in such a way that you only attract registered Republican voters, and trying to get a sense of which way an election is going to swing, that's going to have a dramatic effect on your conclusions. It's going to look like, well, you know, the Republicans are going to win, when who knows? Again, it's just the idea of not getting a representative sample, but selection bias is all about the sample. Then we'll have participation bias. Okay. Now, again, we're dealing with sample. And so both of these are dealing with sampling, but participation bias. If a person is not randomly selected and they take action to choose to be part of sample, maybe they have a reason for wanting to be part of the survey or part of the sample. And that is particular. So where does this come up? I alluded to if Fox News or MSNBC has you text in, a yes or no to a question, that's participation. You're not asked to be part of, the study. You were not randomly selected. You made the choice to, text in your answer, and you may feel very strongly towards one aspect of it or not. So again, but it is all about folks who are choosing to be part of the process and not randomly selected. Okay. So,
I would like to ask you. Every single religion will kill.
So here's a case study I'm reading. This came from the Literary Digest, and this is a popular magazine from the 1930s. And they had successfully predicted the outcomes of several elections using large polls. So doing polling. So this is sampling. 1936, the editors of Literary Digest conducted a particularly large poll in advance of a presidential election. They randomly chose a sample of 10 million people from various lists. Now, so that's a big sample, but percentage-wise, given there's 300 million people in the country, it's still a sample of all possible voters, including names and telephone books and rosters of country clubs. They mailed a postcard ballot to each of these 10 million people, and about 2.4 million actually returned. So again, this is where we could have participation bias, because it's only the folks who chose to send back their postcard ballot were counted. Now, based on those return ballots, the Literary Digest predicted that Alf Landon would win the presidency, and by a margin of 57% to 43%. So not even close. It was a decisive victory over the incumbent Franklin Delano Roosevelt. So we already know, Alf Landon was never president. He didn't win. But instead, at the end of the day, Roosevelt won the election with 62% of the popular vote. So how did it go wrong? So when looking at how they chose to send out those 10 million ballots by either telephone people who had a telephone number, which meant they had a place of residency, and then also country clubs, they tend to be more affluent. So right there from those 10 million people, they tend to be more affluent, and folks who are more affluent tend to be more Republican. And then out of that 10 million people, only 2.4 what actually sent ballots back. And those are the ones who felt very strongly towards Alf Landon. So you definitely have some bias going on there in terms of who was selected. So that is in the selection bias, how they chose the 10 million to send them to. The 2.4 million was that actually sent them back, then had participation bias. Right. So, and we're still, most elections were fairly on. Now in 2016, it was off. So when Donald Trump won the presidency, all the polls indicated he was not, and so in those swing states, he was down in the polls in Michigan, Wisconsin, and Pennsylvania. Ended up winning all three of those states, and they're still trying to figure out exactly what went wrong there in terms of their polling. So to be that far off. All right. Yeah. Let's look at another example. Talk about confounding variables. All right. So we said these are not variables of interest, but even in a well-written study where you have clearly defined goals and you know what your variables of interest are, there still could be these other variables that are not intended to be there, but just inherently show up there. So looking at an example of that. Right, so radon is a radioactive, you don't want to mess with radon, but it's a radioactive gas produced by natural processes. In this case, the decay of uranium in the ground. So the gas can leach into buildings through foundation, can accumulate in relatively high concentration if doors and windows of that building are closed. So imagine a study that seeks to determine whether radon gas causes lung cancer by comparing the lung cancer rate in Colorado, where radon gas is fairly common, with the lung cancer rate in Hong Kong, where radon gas is less common.
Sure.
Suppose the study finds that lung cancer rates in the two cities are nearly the same. So they do a study. So Colorado had more radon gas, and Hong Kong had less, but the study ends up showing that the lung cancer rates are about the same. So is it fair to conclude that the radon is not a significant cause of lung cancer? Now, so right off the bat, my gut feeling is no. So what, so our variable of interest was definitely the radon gas. And those variables again of the study are the amount of radon in the area and what the lung cancer rate was. So what are confounding variables? Radon gas is not the only cause of lung cancer. Smoking is known, obviously, to be a cause of lung cancer. And the smoking rate in Hong Kong is considerably higher than it is in Colorado. So, maybe that balanced them out. So that smoking rate is what you would have to consider a confounding variable. Does that make sense? So again, the variables of interest there were the amount of radon and then the lung cancer rate. But so but I have to take into account in some way the rate of smoking in each area. So as could also have an effect on lung cancer rate. So, all right. Okay. Now, let's look at the idea of checking that results are presented fairly. This would be number 7 in our list. So here's an example. We've got a school board, and it has created a hubbub when it was announced that 28% of school children were reading below grade level. 28%. So that's a fairly considerably large percentage. Reading below grade level, and hence concluded that the methods of teaching reading needed to be changed. The announcement was based on reading tests of which 28% of Boulder school children scored below the national average for their grade. Does the data support the board's conclusion? Okay, so the fact that 28% of Boulder school children, and this hypothetical situation was in Boulder, Colorado. So anyway, the Boulder school children below, the fact that 28% of them scored below the national average implied that 72% were at or above the national average. Therefore, the school board's ominous statement that students reading below grade level made sense only if grade level met the national average score for participating grade. But this interpretation of grade level implied that half the students in the nation are always below grade level at any time. If you always base it on what the national average is, not what really constitutes being above or below a particular grade level. Meaning no matter how well the student scored, half the country is going to be below grade level in that kind of interpretation. So the teaching, who knows, maybe the teaching methods did need changed, but you really couldn't draw the conclusions of that based on the way they presented the data. So that's what, is the data presented fairly? And that would be example what it was not. So okay. Homework for 5B is basically going through the things we have just up to now discussed. And I pretty much have gone through everything. And it throws a lot of, does this study make sense, not make sense? Ask for some definitions of confounding variables. So I'm just looking at this for considering problem number 1. Consider an experiment in which the weights of 6-year-olds are measured. So that's the study. What is the variable of interest in this study? And it gives you literally 6 different choices. And honestly, and looking at the 6 choices, if you just do a process of elimination, this one's an easy one. I mean, so like one choice is the height, what is the variable of interest, and one choice is the height of 6-year-olds, but the study is studying the weight of 6-year-olds. One of the choices is exactly the weight of 6-year-olds, and that's the variable of interest. So Fairly straightforward.
So massive.
So here's number 2, just again, just kind of giving an example of the kind of problems you're going to look at here in 5B. Imagine that a survey of randomly selected people finds that people who used sunscreen were more likely to have been sunburned in the last year. What is the explanation for this result? What explanation for this result seems most likely? And again, you're given 6 choices. So some of your choices that are not correct here, people who use sunscreen have more delicate skin, but who knows? Sunscreen increases your chances of getting a sunburn. No. Sunscreen is useless. That's kind of, I like that one, but no. But the correct choice here is people who use sunscreen are more likely to spend time in the sun. Just, if you're in the sun more, you're probably apt to get sunburned. So,
Better than gets 30 farming guys.
all right.
Mr. Cunningham,
Yes, sir.
I will be right back really quick.
Okay.
I could take care of something.
All right. All right. Let me ask, defining variables of interest, defining confounding variables. Should be okay. All right. So, going to identify potential sources of bias in the following study. So remember, right now we've got 2, selection and participation. So your possible answers here are participation bias only, selection bias only, both selection and participation bias, or no bias, neither. All right, so here is the study. An exit poll designed to predict the winner of a local election uses voluntary surveys with every Republican who votes between 7 and 8 a.m. What do you think?
I feel like it's both.
Yep, and
Yeah.
you will be correct.
Okay.
So you get the participation because of the voluntary nature
Mhm.
of, and you get the selection because it's only Republican voters who vote between 7 and 8 a.m.
Mhm.
All right. So,
Dragon spine dragon. Dragon spine dragon.
so you shouldn't find too much difficulty with this section. There's 22 problems total. And what this is going to set us up with next time on Thursday. And we are going to look at tables and graphs. So actually that is, when we look at organizing data, consolidating it, ways to do that. And so we'll first what we call frequency tables, and how to build a frequency table, pie charts, bar graphs, histogram, and I don't think we'll do stem leaf yet. So, but that will be on Thursday.
Same.
It'll
I
be
was
five
actually-
C. So,
yeah, I
um,
was actually about to say,
so let me go ahead and do this now.
I feel like, how long what she said. I was just- That's their-
So today is the 2nd, so I'm gonna put a due date of the
that's
4th,
also good to
which
know.
is Thursday. And 5B is assigned.
You could break it to-
And um, so we should be able to, by next week, actually move on into chapter 6. In which case we'll be looking at chapter 6, Mary's measures of central tendency, measures of variation. And so that'll be next week. So if that's all I really have today, I've assigned 5B. If there is, if you have any questions or anything you want to work on, stick around. I'll stick around and we can work problems. Otherwise, you are free to go.
All right, thank you, Mr. Cunningham.
All right, you're welcome. See ya.
See ya.